Welcome to the fourth lecture of the ninth week of the course Metal Additive Manufacturing. We have discussed about reverse engineering in this week, and this is the last and the fourth lecture where I am going to take the laboratory demonstration, the second part, where I am going to take you to the DesignX Geomagic software. Majorly, there are 4 steps in data capturing using 3D scanner. Number 1, creating the project. Number 2, alignment with the rotary table, the synchronization of the rotary table and the camera and the software that is to be made sure. Then we capture the data actually, we start the scanning process, and then we clean the data. That is, we edit the data that has been obtained using the scanner, using the structured light that we have got in the previous lecture. Now we will start our software, which is Geomagic. So I am going to start the file. I am going to open the Geomagic DesignX software. If I click on the Geomagic icon on the desktop, it will start opening the software. So if I get any scan model, if I have any scan model, so I have to now create a solid model out of that. So that part would be taken care here in the Geomagic, where I will try to create a solid model. It will follow through certain steps, that is bringing the data or bringing the file or importing the file that is scanned using the scanner, then trying to put that file in the layout of my work area here in the software. Then we have different tabs here in the software. In the right side you can see there is an analyzer, that is, it is written as accuracy analyzer. So each time and again we need to click and see whether how accurate our obtained model is to the actual model. So accuracy analyzer will tell us that based upon the color patterns, so it will just project the obtained model on the colors, that how exactly it is matching. So there are different uses of the different tabs which are available here. For example, home, live capture, points, polygons. So from the import option, I try to get the file imported into it. So in the class specimen folder, there is a file kept as class specimen. It is in the .stl format. I need to put the file in this one, import the file using this import button. So the file is imported here. So we can see that this is the model that is obtained. As far as possible, we have tried to clean it there itself while scanning. All the unrequired or unwanted points were all deleted, but still it has certain issues like the surface finish, like the edges are quite distorted. This is the way how the data is captured there. So using the dimensions or using the original dimensions or the help of the software tools, we will try to make it as soft or as clean as possible. So there is add plane. If I first I need to add a plane here, so I will select 1, 2, 3, 4 points and I will generate a plane here. So this will become a base plane, so based upon which the object would be created over it. So there is a blue line in the on outside the boundary of the object. So this is a virtual plane now. So now I go to the sketch menu bar. Now in this mesh sketch is there on the left of the ribbon. See, if I click it, so it will show mesh sketch and sketches. It will now help us to create the outline of the virtual plane. Virtual outline would be seen when we try to click it. It will be now in this form. Now you can see when we mesh sketch setup is opened, it is showing the virtual plane here. So it is showing that how closely we can move the polygon sections here. You can see these dotted blue lines here. That is the intersection of the touch area contact area of the virtual plane with the object. So it has to just touch the boundary. So now you can see this purple line. This purple line is showing the object outline. So there are default models down here, meshes, sketches, references. So we can hide and unhide the points. So once it is opened, you can say all the ribbons are now active there, these are enabled. In auto sketch also we can come. So we can just try to make the line as straight as possible. So we select this line, so I'm just extending it so that I make sure that the line is properly straightened. So the nodes are extended beyond the boundaries of the object. So this line is now put here. Now I need to create constraints. I'll make another perpendicular line to it. So again I fix line, the second line is fixed. Now the nodes of the second lines are also extended. So we have got one straight line, one horizontal and one vertical line. So using this procedure only, we try to put the lines in the perpendicular and to the horizontal of the one line that we started in the beginning as the which we picked the longer edge of the object here. So in this case, we have then got the whole base of the object. Using the similar methodology, we try to create the side surfaces and the top surface of the model. Then the dome, the cut pattern, the dome cavity, all those would be made further. For those, we can create a tool over it. Depending upon the angle of the pattern that we have, we can generate a surface over it. For example, this. So we have created say there is an extended volume over that is kept over the body, that is kept at an angle. For example, this is 30-degree angle or so. So that is created. Now this object that is in yellow color, that will act as a tool. It will cut the object and try to make it straight. So you can see in the model, we say cut. We select in the model tab, we can select cut. So this is the body that is created, the top and the surfaces are created. Now the second part, we have generated a surface here. When we extrude it, we get a tool kind of the body here. That tool, why I am calling it tool, because this I will use to cut the portion of my object. So this is the target body, green one is the target body. Now another one is the tool body. Now green is the target body, so that I'll just try to cut it there. There are three options which are asked here: merge, cut, intersect. So I need to cut it. So using the created body that was just used to create the angle over here, we have cut our original body. We have cut our original body, and now using the accuracy analyzer, we can see that maximum part is green. So what is this accuracy analyzer telling? The green part is telling that this is closest to the original body. Yes, there are red portions, that means there is no material there. There are portions which are blue or so, that means it is on the upper side. The material is extended there. So in this case, you can see the colors vary from blue to red. In between we have green. So red means cavity at the top, and down there it is blue. That means the material is excess over there. So it is cutting the material there. Because we have not created dome, so wherever dome was it is showing blue color. Wherever dome cavity is there, it is showing no material, that is showing red here. So it is almost complete. We have tried to make it as close as possible. We have tried to make it very close to the final object that we need. So this is the object, this is the data that we have got from the camera. So still there is a cavity. We need to create a plane here, then we can create this pocket here. So again, the red zone means there is no material. So I will create a virtual plane here. So this will be a third plane. So using the plane menu, so we will create a plane here. So we come to the plane menu in the model, the plane ribbon in the model. We select plane, then we select, or in the sketch itself we can select mesh sketch setup. So using the sketch menu, mesh sketch setup, again we can try to align it. We can see, so where is the plane just touching my virtual plane. So wherever it touches, from there the plane would be there. So I'm trying to just see, okay, this is complete or almost closest alignment with the upper surface of the body. So this is again a plane is being created at the top. Again, as we did for the bottom plane, I'm just showing it again. So we can use the line options or the sketch options. So in the sketch, I go to the ribbon where line is here. If I create a line here, I'll create another line that is parallel to this line. So these two lines are already generated here. So we can make them parallel to each other. So the lines are to be made constant, the lines are to be made parallel to each other. So again I come to the line command here. So it is now being made fixed here. So it is asking vertical or horizontal. So both the lines are now selected. We select parallel. So both the lines would be parallel to each other now. So the nodes of the lines, that is the ends of the line, it is a line segment which has fixed ends here. So I'm just extending them so that I see them clearly. So to put the pocket, the actual depth of the pocket is to be taken, which was seen when we touched the virtual plane there. That was around 3 mm. So again I put the constraints here. To put the pocket, I need to have the boundary of the pocket, where the pocket is required. I now put the lines here, a perpendicular to the line that is generated on the top. So this is made perpendicular to it. I'm just extended it so that I get it very clear. Again, a similar line is created between the two nodes up there. So these are again to be extended. Okay, this dimension could also be seen. What is the actual distance? It is yet tilted, it is not parallel, that is why the dimensions were not coming correct. So I again make the small line that is up there perpendicular to the adjacent line. So with these two lines now become parallel, now the dimensions have come. Now these dimensions, it was showing in points, but it is now put what we were known about 24 mm. Okay, these two lines are now perpendicular, and the lines within which dimensions are given are parallel to each other. Now we will create the width. So we can see one line. Okay. So to fix the width, we will also just create a line here. We will fix the dimension 10.2 mm. So the fill or the extension of the line is again made, and we create then. Now we can trim the line from the same tools ribbon here in the sketch tab. So we are trimming it. The unwanted part is all trimmed. So again we'll come to model options. It is the model tab. We'll try to extrude so that we create one tool and the main body remains as our material. So that is cut, and we get this pocket in the model. So now this is created. In the model, it is extruded. extruded out, and down there side it is 3 mm. So it becomes my tool, my base objects becomes the material, and this will now help us to cut the pocket. But this pocket definitely is not showing the fillet or the curved edges. So if we now perform the Boolean operations over it, so we can again cut it. So we'll cut it. It is showing right intersect. The tool, merge, cut, intersect. I'll just select tool, select the material. Right. Previously the options were swapped. So it just cut, the tool was selected as the material and the material was selected as tool. So now it is corrected. So now again this green zone is showing what the gotten captured data using the scanner and the data that is required, how it is showing closer to it. This only gave us the dimension that the depth is 3 mm while putting the virtual plane there. Now we can put the fillets here. The fillets are also calculated from the data or from the captured data. So we will put 1 mm fillet here. Each fillet is 1 mm. It is seen using the, while putting the dots here in the original data that is captured. So those fillets are put in the all 4 corners here, all 4 edges. So we can hide them, as sometimes the corner is not, we are not able to select. So okay, now we can select the corner. We have hidden the original object. So these 4 fillets are now put here, all with 1 mm dia. These pockets are now generated. These fillets are generated and the pocket is now complete. The maximum part you can see is showing the green zone. Using the accuracy analyzer, time and again, we are able to find how close our object is to the captured data. So now we are now left with these slots here and the dome. So again, I'll go to the model tab, the reference geometry ribbon, and select the plane. We'll add a plane here. I'll select 3 points here and put a plane here. Again, I'll come to the sketch options, that is sketch tab. I'll again create mesh sketch setup. So this is a virtual plane again. So this will also again give me the pink dotted boundary or the purple dotted boundary. So I will try to see where the surface is required. Okay, now we have got this line here. So we will now hide our mesh that is the captured data. Now this is the circle that is to be generated. Which option is suitable to generate a circle? There are certain options available. We can create a circle directly while putting radius or using 3 points or 3 R's. So we'll select circle. So we can create circle using this. Okay, we have now generated a circle. Again, we will have the mesh body. We'll have the dimensions of the depth of the slot from here, where is circle slot, and we'll have the solid body. This circle will now again be used as a tool. So we'll extrude it and create a tool out of it. So I exit. Again, I come to model option. It is asking to create a tool out of it, or create a tool means I am creating another body. The depth is again 3 mm here. So we come to extruded part. We operate the Boolean operation here. We select the tool and the target body. So, now it is cut extruded. The target body and tool body, again it is coming closer to what the CAD model would look like or should look like. Now, this is the mesh body that we have got. Mesh body means it's the captured data that we have got from the scanner. So, the CAD model now is when it is projected over it. So, we can see the maximum part is green, it is close to what we have got in the data. So, now only the red portion and the blue portion is left, that is the dome. So, this is my base object. So, now I will create the dome for it. Cavity, dome cavity, and the projected or the protruded dome here. So, I will again create a virtual plane to see whether how to see the circularity of the dome. So, mesh SketchUp setup. So, mesh sketch setup will give me this line boundary. This line boundary would be the outer boundary of the dome. So, it is actually it looks like it is a half of the total circle, it is a semicircle. So, we have created this kind of the semicircle body. We will try to see how to generate a circle out of it, and we will try to generate the dome. So, number 1 is circularity, number 2 the dome, the straightness of the diameter of this circle. So, we have just selected circle from this sketch. So, we will just try to make a circle using 3 points here. We have selected 3 points and we are trying to fix a circle. This is always the skill of the operator who is trying to do this. So, we are trying to generate this body. So, we have created this circle. So, it is divided into half part here. So, using a fully rebuilt body, the project oriented user interface is always there. So, half of this has to be dome, half of this has to be cavity. It depends upon the sometimes we also take the photograph of the object and we put them together. This helps the user to have better results. The softwares are always created to make it as simple as possible. So, it requires little effort to set up parameters, to speed up the scanning by letting the user focus on the task that is there in the hand. So, we can see now it is connected, the circle that is generated, that is connected to the base model here. Okay, I am trying to create the diameter of it. Yes, the diameter is almost matching. I am just trying to create a line on the purple boundary of the object that I have got using the virtual scale. So, it is again fixed, it is extended so that we try to intersect it. So, then the remaining part is now trimmed. So, we are now divided into 2 parts because creating a single circle would have been difficult to create separate dome and cavity dome. So, both of them will be taken separately. So, half circle is generated, that is semicircle is generated. So, now using the accuracy analyzer, we will see the height of the dome. So, taking the height of the dome and the circularity, we have to keep matching it using the accuracy analyzer. First, you can see where does it touch. It just when it just touches, you can see a small in the center and the green part is there. So, that means it is exactly matching the mesh body. When I say mesh body, that is the captured data. So, this is the height of the dome that is there, that we have got, because it was just showing the touch, the green portion there at the center. Now we need to create the circularity or the curvature over the top of it. So the camera lens that we used had 25 mm focal length. So that is why it has given the great or the close data that we have got. So we have created the dome while keep on matching the curvature to the mesh body and getting the green part as close as possible. There are certain small points that we need to take here when we try to scan, like the temperature of the room must not be more than 32 degrees, and the field of view is within 760 mm. So these points we need to take care. So now I need to create the dome cavity. I'll again add a plane. I'll select a plane. I'll pick multiple points on the plane. On the top of the, we will create a plane. Now I'll again create a plane on the surface. This plane is generated. So this is plane 6. It is also showing the number of the plane. It keeps on adding the commands that we are the planes that we are generating. So now this is the plane that is generated, and also we have got the outer line of the cavity. So again I select the circle option there. I try to match it here. It is also now showing the full circle. Now if using this I need to generate the cavity. So there is small misalignment. So outer pink color or the purple color is not to be adjusted according to. So it is the circle that is generated here, you can see it is larger than the upper dome. So we need to connect these two. The dome and the cavity dome, these were a complete full circle. So the circle that we generated is not working properly as per a requirement. So using 3 points, we are trying to match the circle as close as possible. These small hiccups do come when we try to scan something, because it is anyway the scan data. So let me try to put this one circle. So I will try to cut the extended circle part. So we will cut the cavity. So I will trim the other portion that is not required. So this part is the upper dome, and the part we are not to create now is the cavity dome. So using trim options, now we will try to exit the trim, and we will try to make the circle as close to the upper dome. So through this right edge of the upper dome also, I will try to see what is the issue. Sometimes when the edge is selected, that the circular edge, that doesn't match perfectly with the virtual plane. because the edge is distorted. So, because of the distorted edge at the end, or the distorted circular edge, it is showing the larger circle. So, we need to now match it properly, and it was not the exact diameter. Yes, now the problem is sorted out. The circle we tried to generate was not the exact diameter, there is a small gap in the center. So, we have created this circle over it, semicircle over it. So, again the depth is t mm, again the dimension is 3 mm here, the depth is 3 mm. So, pockets, circle, the dome, everything is 3 mm in this object. So, since we need to cut it down, we will again will come to the extrude command and put cut extrude. So, we will get a cavity here using this set called cavity. We need to create the replica of the dome, exact replica we do not know, but we will try to match it with the mesh object and try to see when is the maximum green color coming. So, fillets are also to be put here down there. So, 7.5 is the fillet radius that is to be generated here. So, it is just 7.5 mm radius fillet size here. Now, the fillet is given here and we have created the dome cavity also here. Now, the object or the solid body that we have generated is only always checked through accuracy analyzer. We just noticed that the dome circles were not matching because we thought of that as the exact diameter, but it was not the exact diameter when we actually see. So, you can see maximum of this is green, but still we are not able to get the perfect dome. Obviously, it is not a 1 hour or half an hour job. The operator has to work on it multiple times. It has to sometimes do small manual cuts in the curvature, in the fillet, to make sure that using accuracy analyzer we keep on obtaining the model that is closest to the mesh. Now, we are generating fillet down there. So, small fillets which are observed from the mesh, 0.7 mm fillet is being given here. Now, the fillet is now made 1 mm here or 0.5 mm. So, only small approximations are being taken, then we will match it with the obtained mesh. So, this fillet is also to be given on the edge at the back of the dome. Again, this is given as 1 mm. Sometimes we have the freedom to make the product look little better when we try to print it, or sometimes the fillet requirements are always there to have the good joining in the 3D printing as well. So, those fillets are also put accordingly. So, just to make it look better only, the fillet size is put little larger. So, the blue line which it is showing fillets now. Now, using accuracy analyzer, it is showing that it is good match. So, this is the scanned part, that is the mesh body. We had a dome, the dome cavity, the cut extruded part, the pocket. So, this is a solid model. So, we have now obtained the solid body. So sometimes the design of the object is available, we need to just compare it with the existing design. Sometimes the design is to be generated. So this object that we selected was already distorted. So just to show you that what kind of challenges could come when we try to obtain the data, we have selected this model here. Now we are trying to save this model. So if any of these formats, it could be saved as step format or so, or any, it is being saved in the IGES format. So again, it is being named as class specimen IGES. So as per requirement, it is saved. So in this way, we have obtained the solid model. Which is close to the mesh model that we generated. There are multiple other things that could be taught or that could have been missed in this lecture. Though the learning of the 3D printing process, I have just shown you the major steps in data capture, the data cleaning during the capture itself, and the alignment, the selection of certain parts when we start decorating of plane, also how do we cut, extrude. General, just like we work in the other solid model developing, we try to work on the data cleaning or data editing using the software Geomagic Design X. We only try to keep it matching using accuracy analyzer and try to see how close it is to the obtained mesh object. This is how reverse engineering works. There will be many things that could have been missed in this lecture. In a way, multiple commands, the multiple options in different tabs, there are multiple other small intricacies in different ribbons or selecting dimensions. The purpose of this lecture was just to have a brief or the trivial introduction to how does editing and data capture happens. Let us meet in the next week. Thank you.